Hello students, today we shall discuss number system of class 9 maths. So we shall start with the number line. Let's do the number line. This is the position of 0. Number line you have already got in the previous class. I am just recalling. So in the right side of the 0 there are positive numbers 1, 2, 3, 4 up to infinity, and in the left side there are negative numbers up to infinity in both sides. Now you see, if I move from left to right, the numbers are increasing, and if I move from right to left, the numbers are decreasing. Now all the numbers we come across in the HSLC level, we can get all the numbers, or we can locate all the numbers in this number line. So let's see the numbers. First, natural numbers. Natural numbers starts from 1. First member is 1. 1, 2, 3, 4 up to infinity. Then whole numbers. Whole numbers start from 0. First member is 0. 0, 1, 2, 3, 4 up to infinity. And next, integers. Integers are written like 0, plus minus 1, plus minus 2, plus minus 3, plus minus 4, and up to infinity. Now you see, first we have got the natural number and the whole number. Natural number starts from 0 and whole number start from natural number start from 1 and whole number starts from 0. So we can have this number in the number line. We can get this number, locate this number. But in case of the integers, there are plus minus. Why plus minus we have mentioned? Because their negative numbers are also considered in case of integers. But in whole number, in natural number and whole number, only the positive numbers, including 0. And remember, 0 is neither positive nor negative. So 0 is also an integer, and both negative and positive numbers are also integers. Then rational numbers. So what are rational numbers? The numbers which can be expressed in the form of p by q, where q is not equal to 0. So these numbers are called rational numbers. Q is not equal to 0. So let's see the examples. Again, if we take the integers 0, plus minus 1, plus minus 2, plus minus 3, these are all integers, because we can express these in the form of p by q. Say 0, we can write 0 by 1. 1, we can write 1 by 1. Say minus 2, we can write minus 2 by 1. So these can be expressed in the form of p by q. These are the p by q form. So p by q, you know, in the fraction this is called numerator and denominator, and in this case the denominator cannot be 0. If denominator is 0, then these are undefined numbers. Suppose if I write 1 by 0, 2 by 0, or like these numbers are undefined actually. Now some more numbers are there in rational numbers. 1 by 2, if I write 1 by 2, 1 by 3, 3 by 5, these are also rational numbers, as these are in the form of p by q. Now one thing, we will find the decimal expansion of these numbers. Suppose 1 by 2. Let's see the decimal expansion. 1 by 2 means we have to divide 1 by 2. Let's divide. So there will be 0.025 10. Now you see we have got the remainder 0. So decimal is terminates here. We cannot proceed further. Answer is 0.5. So decimal expansion of 1 by 2 is 0.5. So this is a terminating decimal. It terminates here. But in case of 1 by 3, if I divide 1 by 3, 0.0, 3 3 is a 9, 1, again 0, 3 3 is a 9, 1, again 0, 3 3 is a 9, remainder 1. It will continue. We cannot get the remainder 0 in this case. So this 3 will be repeating. The answer will be like this, 0.33. So it will be repeating, or you can write 0.3 but simply. So the decimal expansion of 1 by 3 we have got. It is a non-terminating but repeating decimal. The decimal expansion of 1 by 3 is non-terminating but repeating or recurring, you can say. So these two types of decimal expansion in rational numbers are there. And again, if I want to express this decimal expansion in the form of p by q, we can express it. So these are rational numbers. Now irrational numbers. Irrational numbers, the definition, the number which cannot be expressed in the form of this p by q. The numbers we cannot express in the form of p by q. These are called actually irrational numbers. So mainly if we take the square root of the prime number, suppose square root of 2, I am showing the square root of 2. The value of square root of 2, if we find, then it will, we will get 1.41421, and it will be continuing like this. Square root of 3, the value of square root of 3 is 1.73205, and it will be continuing. Root 5, and another number pi. Now you see, these the decimal expansion of these numbers are non-terminating but non-repeating. These numbers are non-terminating and not repeating. These are not repeating, but in rational number we shall get the numbers are repeating. This is the difference. So the decimal expansion of irrational numbers are always non-terminating and non-repeating or non-recurring. So now we shall start the exercise 1.1 of textbook. Now you see number one question. You see number 1, is 0 is a rational number? First, can you write in the form of p by q, where p and q are integer and q is not equal to 0? So let's answer it. First, is 0 is a rational number? Answer will be yes. And 0 we can express in the form of p by q, simply 0 by 1. So this is p by q form, and q is not equal to 0. Q means denominator is not equal to 0. So this is a rational number, and we have expressed it. Okay, next, number 2. Find 6 rational numbers between 3 and 4. Now one thing you see, in this number line, in between any two consecutive numbers, say 3 4 2 3 0 1, these are all consecutive numbers. In between any two consecutive numbers, we can get the infinite numbers. Actually there are infinite numbers in between any two interval. Already in the starting I have told you that all the numbers we come across in the HSLC level are in this number line. It is also called real number line. Now we have to write just 6 numbers. So I am showing the simple method to find. You can follow other methods, but I am showing here the simple method to find the rational numbers. I have written 3 and 4. We have to find the numbers between 3 and 4. So 3 we can express 3 by 1, and 4 we can express 4 by 1 simply. Now 3 by this rational number we shall multiply it by 10, and this also multiply by 10. We have just enlarged the numbers in order to find the 6 rational numbers, because in between 3 and 4 we cannot find, so we have maximized it. So answer will be 30 by 10, and it is 40 by 10. Now you see the denominators are same and numerators are 30 and 40. So excluding 30 and 40 we can write 6 rational numbers, though there are infinite numbers. So I shall write just 6 rational numbers. Therefore 6 rational numbers are excluding 30, 31 by 10, 32 by 10, 33 by 10, 34 by 10, 35 by 10, 36 by 10. See, 6 rational numbers are there. So your answer may be different because there are infinite numbers, I already told. So your answers may be different, but I have written just these 6 rational numbers. Anyway, next, number 3, find the 5 rational numbers between 3 by 5 and 4 by 5. So 3 by 5 and 4 by 5. So let's multiply by 10. 30 by 50, 40 by 50. Now again see, denominators are same, and in between 30 and 40 we can find the 5 rational numbers excluding 30 and 40. Therefore 5 rational numbers are 31 by 50, 32 by 50, 33 by 50, 34 by 50, and 35 by 50. See, these are the 5 rational numbers. Thank you. That's all for this video.